is Isaac Langer, there's Mike Gonzalez, and Logan Lawrence. We're Group 35, and we're doing the AE1601 glider project. So an overview of this is we're going to do initial requirements, some measures of success, design processes, the performance of our glider, and the calculations. The requirements is that the glider was to demonstrate stable and efficient flight. It needed to be lightweight, aerodynamically efficient, and capable of maintaining longitudinal stability. Additionally, it had to fit within a 16 by 16 inch square box to comply with size restraints, and it had to fly a minimum of 20 feet, as well as being unpowered. To measure our success, it would be flight stability, which is assessing how well the glider maintains a straight, stable path, the flight duration, so how long it flies, and the glide ratio, so the distance traveled horizontally compared to the height lost. So some alternative designs we considered was the flat wing design, which is a simple flat wing structure, dihedral wing design, which means that the wing is angled up, and V-tail configuration, which is a tail in the shape of a V that reduces drag while keeping both pitch and yaw movements. Some pros of flat wing design is it's easy to construct, it's lightweight, however it has poor stability and control. For the dihedral wing, it has enhanced lateral stability, however it does have increased drag and it's difficult to manufacture. And for the V-tail, it has decreased drag, but it is more complex to construct. So our highest probability of success was the V-tail initially, because we thought that it had the highest chances of flying well due to its increased drag, as well as keeping the same stability in both pitch and yaw. For the sizing, we knew that the glider needed to have long wings with a short chord to maximize the lift and minimize the drag. So we made our wing 16 inches with a chord of 1.5 inches. The length of the whole glider altogether was 10 inches to save on weight. Here are some dimensions. So the length of the glider is 10 inches, the wing length is 8, total wing length is 16. The stabilizer height is 1.5, and the stabilizer length is also 1.5. For a glider height, it is 2 inches in total. Our initial design was a dihedral wing with a moderate angle to balance stability and drag, combined with a lightweight fuselage, which is about 10 inches, and a V-tail configuration for decreased drag and control. Here are the initial designs. So after our first flight, we realized that the V-tail was not what we needed, so we switched over to a conventional tail in order to get increased control in the pitch and yaw. Our overall performance after modification. Our initial tests showed that the glider only flew like 20 feet 50% of the time, so we switched over to this conventional tail. After that, it flew straight, however, it wasn't flying for nearly long enough, so we decided to do something else as well.
Hello, I'm Micah Gonzalez, and I'll be taking over from here. For our final design iteration, we added 30 grams of Play-Doh to get that perfect CG ratio in front of the wing, and we added a slight wing angle of attack for more constant lift. Our test showed that the glider met the requirements for the flight stability and duration, flew very long and far, but we just wanted some more refinement. As I mentioned in the last slide, we added an angle there that was approximately 10 degrees, and what that did is just gave us a little bit more lift and improved our CG and gliding ratio. So that was a good little trick there. For the CG, the wing chord is about 1.5 inches right here, and 20% of 1.5 inches is 0.3 inches. So we put the Play-Doh on the front to ensure that the CG was approximately 0.3 inches in front of the quarter chord point to ensure the maximum stability for the aircraft. For our CL and CD, we used the dimensions provided in the dimension slide, and we calculated the CL and CD. The CL was calculated to be approximately 0.865, and the CD was estimated to be 0.025. Here are the calculations for the coefficient of lift. We found our weight, we found our wing planform area, the wingspan, the flight velocity. This was taken from the video. We plugged it into the formula here, and we got this nice little number here for our lift coefficient. Then we calculated the coefficient of drag using this, using the simple formula that we use our aspect ratio, surface area equals B times C from the previous calculations, and we use the coefficient of drag here, and the formula provided, did the calculation. Since we're assuming zero drag lift coefficient, we just add the two values together here and we get 0.025. So how did the iterations affect our final design? The design iterations led to a significant improvement in stability and glide ratio. The glider was more efficient and reliable. It wasn't gliding left or right anymore. It was just going straight and far, and that's exactly what we wanted. So here's our video. About 60 feet in that video. I didn't even throw it as hard as I could have, and the angle of release wasn't even that good in that video. So, did we meet the final requirements? Yes, we did. We well exceeded the 20-foot limit and went over 80 feet at some times. So, for our conclusion, our best flight was around 80 feet, and the glider was very stable. It flew straight, didn't go left or right, didn't come back on itself, just flew straight. It was small enough to remain in the 16 by 16 box and flew great. So some things we could do better, however, is our manufacturing of the glider was not very good, and our initial design process wasn't very good. There were plenty of defects that made the glider flew. I don't know if you noticed, but there was a chip out of the wing at one point. So if we could have made it a little better, thrown it a little more protected, it would have been obviously a lot better. Another change we could have made was make our tail section larger. We could have more pitch and yaw control to just a little bit of extra stability. If the elevators were bigger, then the glider would be less likely to pitch down. And that would just things to maximize that. Here are references. Thank you.